You know what's kind of crazy? A recent study found that over 60% of people actually preferred AI-generated videos over ones made by humans.
Really? Wow, that's pretty amazing when you think about how complex video creation is and how far AI has come. Yeah.
Yeah, it's wild. It really shows you how sophisticated these algorithms are getting, how good they are at replicating or even surpassing human creativity. And that's what we're diving into today, AI-powered video generation.
Sounds fun.
Specifically, we're going deep on a method called TrackGo.
TrackGo.
It's all about control, giving users the power to make a character move exactly how they want, for example, or add some cool effects like making an object float or disappear.
It's almost like having a virtual puppet master's toolkit, right?
Exactly. You're basically manipulating video with incredible precision using tools like masks and arrows. But before we get into the specifics of TrackGo, let's talk about some of the challenges that existing methods have faced. You know, the stuff that came before.
Sure. I think it's important to understand the context, why these new methods are so groundbreaking.
Right. So the source material mentions drag anything and boximator as examples of older techniques. What were their limitations? Like, what were they not so great at?
Well, imagine you're trying to make a character wave their hand in a video.
Okay, got it.
An older method like drag anything might try to track the hand by identifying a central point and creating a sort of heat map around it, like a spotlight following the hand.
Ah, okay, I see. So it's predicting where the hand will go based on that central point.
Precisely. But this approach can be a bit clumsy, you know? It might not accurately capture those subtle movements of the fingers. And if there's other stuff moving nearby, it can get easily confused.
So it's not very precise, especially in complex scenes.
Hmm.
What about boximator? How does that work?
Boximator uses bounding boxes, like drawing a rectangle around the hand, to define the area of movement. But that often ends up capturing part of the background as well, right? Like if the hand is in front of a tree, the box would include the tree too.
Right. That makes sense. So the background might start moving with the hand, or the tree might even become part of the hand's animation.
Exactly. It can create some really weird and unnatural looking effects. So a lot of these older methods struggled with precision and also with keeping the background separate from the object being controlled.
It sounds like they were kind of hitting a wall, technologically speaking.
Yeah, they were. And on top of that, a lot of those older methods relied on very complex AI architectures, meaning they could be really slow and require a ton of computing power.
Not exactly ideal for the average person who just wants to make a cool video on their computer. So is that where TrackGo comes in?
Yes. TrackGo takes a totally different approach. Instead of central points or bounding boxes, it uses something called freeform masks. Have you ever used masks in photo editing software?
Oh, yeah, all the time.
Yeah.
It's like selecting specific areas of an image.
Exactly. So with TrackGo, you can literally use a digital brush to paint over the object you want to move in each frame of your video. You're creating a mask that tells the AI precisely what to focus on.
That's really cool. So it's like giving the AI a visual guide, showing it exactly what you want to manipulate.
Precisely. And then to make the object move, you just draw arrows to indicate the desired trajectory.
So like I could draw a path for, say, a bird to fly across the screen, like a graceful arc through the sky.
Exactly. And behind the scenes, TrackGo does some really clever things with this information. First, it automatically extracts what are called point trajectories from the masks and arrows you've drawn.
Point trajectories, what are those?
Imagine connecting the dots along that path you drew for the bird.
Okay.
Those dots represent key points in the bird's movement, and TrackGo uses them to create a very detailed map of the bird's journey across the video frames.
Ah, I see. It's kind of like creating keyframes in traditional animation.
Yeah.
But the AI is doing it automatically based on your input.
That's a great analogy. And once TrackGo has these point trajectories, it uses them to guide the video generation process.
Okay, so we have the roadmap, the point trajectories, but how does it actually create the video? Where does the visual magic happen?
Well, TrackGo builds on top of an existing AI model called a stable video diffusion model, or SVD.
SVD, got it.
Think of SVD as a super talented artist who can paint incredibly realistic looking videos.
Okay, I can picture that. So SVD is the artist, and TrackGo is like the art director, using those point trajectories to tell SVD exactly what to paint and how to paint it.
That's a fantastic way to put it. And this is why point trajectories are so effective. They give you this fine-grained control over movement and can capture really complex, nuanced motion. Like, imagine making a character's hair flow in the wind or fingers tap on a table. It can handle that level of detail.
That's really impressive. This is definitely getting pretty technical, but I'm curious to know more about how TrackGo actually generates those point trajectories? Like, how does it translate those masks and arrows into a set of points that it can then use to guide the SVD?
It is pretty complicated, but essentially it uses a combination of different AI techniques.
Okay, lay it on me.
First, it uses something called DV, which is like giving the AI X-ray vision. It can automatically identify the different components in the video. So in our bird example, it would separate the bird from the sky and the trees, essentially understanding what it's working with.
So it's like the AI is learning to see the world the way we do, recognizing different objects and their boundaries.
Exactly. Then it uses another technique called K-means to select the most important points within those masks, the points that will define the bird's motion path. It's like picking out the brightest stars in a constellation, the ones that will guide you.
So K-means helps determine which points are crucial for defining the movement.
Precisely. And finally, it uses something called co-tracker to track those selected points as they move over time, connecting the dots, so to speak, between different frames to create those smooth, continuous point trajectories.
Wow, it really is amazing how these different AI techniques work together. It's like a well-coordinated team, each with its own specialized role. But all this processing must take forever, right?
That's what's so impressive. It doesn't. The researchers actually trained the AI on a massive data set of over 110,000 video clips. So the AI has already learned a ton about how objects move in the real world, and that helps it generate those trajectories much faster.
So it's like the AI has already done its homework, studying tons of examples, which makes it much quicker on its feet when it comes to processing new information.
Exactly. But then the AI has to figure out how to integrate all that motion information into that stable video diffusion model we talked about, and that's where the TrackAdapter comes in.
TrackAdapter. Okay, so what does that do?
Think of TrackAdapter as a translator that helps SVD understand those point trajectories and use them to guide the video generation process.
Oh, okay, I see.
Remember when we briefly talked about temporal self-attention layers?
Those sound familiar, but refresh my memory. What are they exactly?
They're a part of the SVD model that helps it understand the relationships between different frames in a video, allowing it to create smooth and coherent motion over time. So the video looks like a natural sequence of events, not a bunch of disconnected images.
Right, it's what makes the video flow, basically.
Exactly. And TrackAdapter works by injecting the detailed motion information from those point trajectories directly into these temporal self-attention layers.
So it's like whispering instructions to the artist, telling SVD exactly how each element should move according to the path you've drawn.
You got it. And what's even more impressive is that the TrackAdapter has this dual branch architecture.
Dual branch, interesting. What's that all about?
Well, one branch focuses specifically on the object you've masked, like that bird we were talking about. It makes sure that bird follows your exact trajectory. The other branch keeps an eye on the rest of the video, making sure the background stays consistent and doesn't get messed up by the bird's movement.
Ah, that's smart. So it's like a conductor leading an orchestra, making sure each instrument plays its part perfectly, but also making sure the whole symphony sounds harmonious.
That's a perfect analogy. And this dual branch design is one of the big reasons why TrackGo is so effective. It's what allows for such precise object motion, but keeps everything else looking natural and in place.
Okay, I'm definitely getting a better sense of how TrackGo works, and it sounds incredibly promising. But does it actually deliver? Does it perform better than those older methods we talked about?
It does. The researchers put TrackGo through a battery of tests measuring video quality, image quality, and how well the generated video actually matched the user's instructions. They used several metrics to assess performance.
And what did they find? Did TrackGo hold up under scrutiny?
It did. They used metrics like FVD, which measures overall video quality, and FID, which focuses specifically on image quality.
It's like judging a video on its technical merits, how good the visuals actually are.
Exactly. And they also used something called OBJMC, which measures how faithfully the generated video followed the user's instructions. So if you told the AI to make the bird fly in a circle, OBJMC would check if the bird actually did that.
It's like the AI is being graded on how well it follows directions.
Exactly. And across all those metrics, TrackGo consistently outperformed existing methods like drag anything and drag NUWA. The videos generated by TrackGo were not only more visually appealing, but also much more accurate in terms of doing what the user wanted.
So it's not just about pretty pictures, it's about giving users real control over the creative process.
Precisely. And here's the kicker. It achieved all of this while also being much more efficient than those other methods.
Really? More efficient, meaning faster and less computationally demanding.
Exactly. It requires fewer additional parameters, which makes it less resource intensive. And it also has a faster inference speed, which means it can generate those videos more quickly.
Okay, so better results, faster processing, and lower computational requirements. That sounds like a win-win-win situation. But you've convinced me on the technical side. Can you give me some real-world examples of what this could be used for? Like, how would this actually change things for people who create videos?
The possibilities are really exciting. Imagine video game developers, right? They could use TrackGo to easily animate their characters. Just sketch out a movement, and the AI generates the animation.
So no more complex coding or expensive motion capture studios.
Exactly. Or filmmakers could use it to create complex visual effects without needing a huge team of CGI artists. The time and cost savings would be huge.
It sounds like it could revolutionize the entire video production pipeline.
Absolutely. And it's not just entertainment. Think about interactive educational videos that respond to a student's input or personalized marketing content that really grabs people's attention.
It's really like opening up a whole new world of possibilities for storytelling and communication.
Exactly. But before we get too carried away with all the amazing things TrackGo can do, we should acknowledge that, like any new technology, it does have its limitations.
Right, it can't be perfect.
Yeah.
What are some of the things that TrackGo still needs to improve on?
Well, one of the main limitations is that it can struggle with very large movements. If you try to make an object move too far or too quickly, the generated video can start to look distorted.
Okay, so it's good for precise movements, but maybe not for those grand sweeping actions.
Yeah, that's a good way to put it. And another limitation is that right now it can't really handle 3D rotation information. So if you want to make an object rotate realistically, it's not quite there yet. It can only handle movement in 2 dimensions.
So those are definitely areas for improvement. But it's still early days, right?
Exactly. And the researchers are already working on solutions to address those limitations.
That's great to hear. I'm really excited to see where this technology goes in the future. But let's take a moment to recap what we've learned about TrackGo so far.
Okay, so here are a few key takeaways. TrackGo is a new AI-powered video generation method that lets you control object motion with incredible precision using simple tools like masks and arrows.
Got it.
It uses something called point trajectories, which are automatically generated from your input, to give the AI a detailed blueprint for the movement. The TrackAdapter is another key innovation, allowing TrackGo to seamlessly integrate your instructions into the video generation process while keeping the background consistent and looking good.
Right.
TrackGo also outperforms existing methods in terms of video quality, accuracy, and efficiency, which is a pretty big deal. And it's already showing how it can be used for things like video games, filmmaking, education, and even marketing.
This has been a really fascinating deep dive. It's incredible to see how AI is changing the way we think about video creation and storytelling.
I agree. It's a really exciting time to be following this field.
Well, let's take a quick break, and when we come back, we'll explore some other groundbreaking research that's happening in the world of AI-powered video generation.
Sounds good. You know, one thing that really struck me about this whole TrackGo thing is how much people actually liked the videos it created.
Oh, yeah, you mentioned that earlier. Something about people preferring the TrackGo videos over the other methods.
It's more than just preference. It's that people consistently rated the TrackGo videos as having higher quality, even compared to human-made ones in some cases.
Wow, that's a pretty big statement, especially when we're talking about something as subjective as video quality.
It is. They had people look at videos side by side made with TrackGo, Drag Anything, Drag NUWA, you name it. And a significant majority, over 60% actually, chose TrackGo as having the best overall quality.
Okay, that's a huge margin.
Yeah.
But I'm curious, what were they actually judging? Like, what made the TrackGo videos stand out in their eyes?
They were looking at a couple of things. First, how closely the generated video matched the user's instructions. Like, did the object move along the path the user drew, that kind of thing?
Okay, so accuracy of control was definitely a factor.
Right. And then second, just the overall quality of the video itself.
So things like whether the movement looked natural, if the details were preserved, that sort of thing.
Yeah, exactly. Like, did the background stay consistent? Did everything look smooth and believable?
It sounds like TrackGo really nailed it on both fronts then.
It seems that way. It's one thing for the scientists behind an AI to say, hey, our algorithm is great. But when you have real people consistently saying they like the output, that's pretty powerful evidence.
I totally agree. It adds a layer of validation that you just can't get from numbers and metrics alone.
Right. Speaking of which,
Yeah.
remember that TrackAdapter we were talking about earlier, the part of TrackGo that helps integrate the motion information into the video generation model?
Oh, yeah, the translator.
Yeah, exactly.
Yeah.
Well, the researchers did a bunch of tests to see how the TrackAdapter actually impacted the AI's performance.
I'm all ears. What did they find out?
Well, they found that adding the TrackAdapter significantly improved the model's ability to focus on the intended object.
Okay, so the object the user was trying to control.
Right. They actually visualized something called attention maps, which basically show where the AI is focusing its attention in each video frame.
So it's like being able to see what the AI is looking at.
Yeah, exactly. And with the TrackAdapter, the AI's attention was way more concentrated on the target object.
It's like the track adapter acts as a focusing lens, keeping the AI's eyes on the prize.
That's a great way to put it. And they also found that the attention mask, the part that tells the AI to ignore certain areas of the video, was crucial in keeping the background from moving along with the target object.
Right, so the background stays put even if the object is moving all over the place.
Exactly. But here's where things get really cool.
Oh, I love when you say that.
They actually discovered they could use that same attention mask to control the background in more subtle ways, too, not just freeze it completely.
Wait, so they could make the background move a little bit even while keeping the focus on the main object?
Yep. They introduced this parameter called tau. Think of it like a slider that controls how much the background is allowed to move.
Okay, I'm picturing it. So if you want the background to stay perfectly still, you set tau super low, and it basically locks it in place.
Right. But if you want the background to move a little bit, maybe to add some depth or parallax to the scene, you can bump up tau a bit.
So it's like fine-tuning the background motion, making sure it complements the foreground action without being too distracting.
Exactly. They found that getting tau just right was crucial for making the whole video look both controlled and natural.
I bet. Too much movement, and the background steals the show. Too little, and it looks stiff and unnatural.
Right. It's all about finding that sweet spot.
I can already imagine filmmakers using this tau thing to create all sorts of amazing effects, like a spaceship flying through a star field and the stars subtly shifting in the background as the ship moves.
That's a perfect example. Or imagine a magical creature flying through a forest and you can use tau to make the leaves and branches sway gently as it passes by.
Oh, that would be so cool. It's like adding a whole new layer of magic and realism to the scene.
It is. But, like with any tool, there are some things to watch out for. If tau is set too low, the background can look completely frozen, which can make the whole thing feel a bit off.
Right, it loses that sense of realism.
Yeah. And on the flip side, if tau is set too high, the background can start moving too much, which can be distracting, or even clash with the main action.
So it's a delicate balance, as with most things in video editing.
Exactly. But overall, I think being able to control the background like this is a huge step forward.
Totally. It gives creators so much more flexibility and control over the final look and feel of their videos.
It does. And it really highlights the power of AI to not just generate content, but to give users the ability to shape and direct that content in really nuanced ways.
It's like we're moving beyond just automation and into the realm of true artistic collaboration between humans and machines.
I totally agree. And I think it's raising some really interesting philosophical questions, too.
Oh, like what? Lay it on me.
Well, if we can control video with this level of precision, if we can basically manipulate reality in a way, where does the line between real and fabricated begin to blur?
That's a deep one.
Yeah.
It's almost like we're entering a new era of digital storytelling, where the boundaries of what's possible are constantly expanding.
Right, and it challenges us to be more critical viewers of media, to question what we're seeing, and to consider the intentions behind the images that are presented to us.
It's both exciting and a little unsettling at the same time, isn't it?
Absolutely. We have these incredible tools at our disposal, but it's up to us to use them wisely and ethically.
Well said. But all this talk about TrackGo is making me really want to see it in action. Like, what kind of videos can it actually create?
Well, luckily, the researchers shared a ton of examples. They showed everything from simple animations like a ball rolling across a table to more complex scenes with multiple characters and dynamic backgrounds.
Okay, I'm definitely intrigued. Let's dive into some of those examples and see what TrackGo can really do. I'm especially curious to see how it handles those more complex scenes with lots of moving elements.
Let's do it. One of the examples that really caught my eye was how they used TrackGo to animate a character in a video
And
game.
that's so cool. So like creating custom animations for your game character.
Exactly. Like imagine designing a victory dance or a special attack move for your character. With TrackGo, you could just draw a mask around your character and then sketch out the movement you want with an arrow.
So no need for complex coding or anything. Just draw it out and the AI handles the rest.
That's the idea. TrackGo would take those simple inputs and generate a smooth, realistic animation that perfectly matches what you had in mind.
Wow. It's like giving players the power to become game designers themselves, creating their own unique animations and movements for their characters. That's amazing.
It is. And they also highlighted how TrackGo is particularly good at things that require a lot of precision, like animating just a character's hand or working with very delicate objects.
I can see how that would be a game changer for creating more lifelike and expressive animations.
Totally. And they also showed examples of TrackGo handling scenes with lots of different things going on.
Like what? A busy city street with cars and people moving around? Or maybe a battlefield with tons of soldiers?
Exactly. They demonstrated how TrackGo can make sure each element in a scene follows its own path, while also making sure the background stays consistent and doesn't get messed up.
So it's like an air traffic controller for video, making sure everything moves smoothly and nothing collides.
That's a great analogy. And they even showed examples of using TrackGo to create some pretty surreal and artistic videos, like making objects float or morph into different shapes.
So it's not just about creating realistic animations, it's also a tool for artistic expression and pushing the boundaries of what's visually possible.
Exactly. And that's one of the things that makes this research so exciting. It's showing how AI can be used not just for practical purposes, but for artistic exploration and pushing the limits of human creativity.
I'm already imagining all the incredible things people are going to create with this. But before we get too carried away, we should probably bring it back down to earth and talk about some of the limitations of TrackGo, right?
Right. We touched on a couple of those earlier, but it's worth taking a deeper dive into the challenges this technology still faces.
Okay, so let's get real for a second. What are some of the things that TrackGo still struggles with?
Well, as we mentioned before, one of the main things is dealing with very large movements.
Right, like trying to animate a rocket launching into space, that kind of thing.
Yeah. If an object moves too far or too quickly, the AI can have trouble keeping up, and the video can start to look distorted.
So it's really good for precise movements, but maybe not for huge, sweeping actions just yet.
Right. It's almost like trying to stretch a rubber band too far. Eventually, it loses its shape and breaks down.
Makes sense. And then what was the other limitation? Something about 3D movement.
Yeah, as it stands now, TrackGo can't really handle 3D rotation information. It can only work with movement in 2 dimensions.
So if you wanted to make an object spin or turn realistically, it wouldn't quite work the way you'd want it to.
Exactly. Right now, it just interprets any rotation as translation, meaning the object kind of slides instead of turning. And that can lead to some pretty wonky-looking results.
So that's definitely an area where they need to make some improvements.
They do. But the good news is that the researchers are already aware of this limitation, and they're actively working on solutions to address it.
That's reassuring. It's always encouraging to know that they're not resting on their laurels. They're still pushing the technology forward.
Exactly. And, in a way, it's those limitations that often drive the most interesting innovations.
It's true. Sometimes those roadblocks force us to come up with even more creative and ingenious solutions.
Right. And I have no doubt that the researchers behind TrackGo and other folks working in this field are going to continue to come up with amazing ways to overcome these challenges and make this technology even more powerful and versatile.
I can't wait to see what they come up with. But in the meantime, let's do a quick recap of the key things we've learned about TrackGo so far.
Sure. Here are the main points to remember.
Hit me.
TrackGo is a new method for controlling object motion in video with incredible precision, and it uses really intuitive tools that anyone can pick up.
Check.
The TrackAdapter is a key innovation that lets TrackGo integrate user instructions into the video generation process while also keeping the background consistent and looking good.
Got it.
TrackGo also outperforms existing methods in terms of video quality, accuracy, and efficiency, which is a huge deal. And it's already showing promise for applications in video games, filmmaking, education, and even marketing.
Okay, so TrackGo is definitely a force to be reckoned with. It sounds like it has the potential to completely revolutionize video creation in so many different ways.
I think so too. And it's just one example of how AI is rapidly changing the landscape of creativity, giving us new tools and pushing the boundaries of what's possible.
Well, On that note, I think it's time for us to shift gears and explore some other groundbreaking research that's happening in the world of AI-powered video generation. But first, we'll take a quick break. We'll be right back to continue our exploration of this amazing field. Okay, we've gone pretty deep on TrackGo now. The tech behind it, what it's good at, what it still needs to work on.
It's been a wild ride.
It has. But before we wrap up, I want to zoom out a bit.
Okay.
Get your take on the bigger picture here. What does TrackGo tell us about where AI and creativity are headed, in the grand scheme of things?
That is a big question. I think TrackGo is a really good illustration of how AI isn't about replacing humans or just automating stuff.
Right.
It's about giving us new powers, new tools to create things we never could before, expanding what's possible with human creativity.
Like AI is becoming our creative partner.
Exactly. And we're not just seeing this in video. Think about music, writing, art. AI is changing how we create across the board.
It's crazy to think that just a few years ago this was all sci-fi stuff, and now it's becoming our reality.
I know, right? And it raises some really interesting questions, too, like, if AI can help us create things that we used to think were exclusively human, what does that even mean for creativity anymore?
Yeah, it's like AI is making us rethink what creativity is and how it works.
Exactly. And I think it's pushing us to be even more innovative and experimental in our own creative work.
No.
If AI can handle some of the technical stuff, it frees us up to focus on the big ideas, the emotional nuances, the things that make art truly special.
That's such a great way to put it. AI is giving us space to be more human in our creativity.
Love that. And I think that's why all of this is so exciting. It's not about replacing human creativity. It's about amplifying it, making it more powerful and accessible.
That's a really inspiring thought. I'm honestly feeling super energized after this conversation, just thinking at all the possibilities.
Me too. And that's the perfect takeaway from this whole TrackGo deep dive.
Yeah.
We're living in a time of incredible technological progress, and the opportunities for creative expression are practically endless. If you've ever wanted to make a movie or animated character, there's no better time than now.
So true. The tools are out there. And who knows, maybe someday one of our listeners will be the ones pushing the boundaries of AI and creativity, inspiring the next wave of artists and creators.
Absolutely.
Well, that's a fantastic note to end on. Thank you so much for joining me on this wild ride through the world of AI-powered video generation. It's been an absolute blast.
Pleasure was all mine.
And to all our listeners out there, thank you for tuning in. Until next time, keep exploring, keep creating, and never stop pushing the limits of what's possible.